The last problem on our second formative assessment is, again, a remainder theorem problem. And the question is, what remainder will you get if you divide the polynomial h of x by x plus 2? And it says to justify your work. So really, I'm going to begin by just stating the remainder theorem as it applies to this particular problem. So I will say this. The remainder you get from dividing h of x by x plus 2 is equal to h of negative 2. So to be clear, the value of x that makes this expression 0, which is negative 2, if I take that value and I plug it into the function h, then whatever I get from that will give me the actual remainder of this division without actually having to go through and do the division. That's the whole point of the remainder theorem. So let me just, and by the way, that's my justification here. I'm just restating the remainder theorem, and I'm making it clear I know what the remainder theorem is and how it applies to this problem. Basically, if I take the value of x that causes this expression to equal 0, and if I plug that value into this function, I will get the same remainder that I would get if I were to actually go through and do long division or reverse tabular method or whatever polynomial division technique you like. So let me just plug in negative 2. Notice I'm taking my time. I first just rewrite the polynomial equation with the negative 2 replacing the x's. I'm careful with my parentheses to enclose my value of x in those parentheses so that I can account for all the signs. Then I'm going to go through and do this calculation. First, the exponents. And now this becomes negative 16 minus 4 plus 32 plus 15. And I end up with 16 plus 15, that's 31. Take away that 4, 27. That's my answer.